In this video we're going to look at how to calculate the product moment correlation coefficient to look at the correlation between two variables. So here we're going to look at height and weight. And in the S1 exam you are quite likely to have a lot of this work done for you because there's a lot of steps. Now in the formula book you can find all of the formula you need, so we'll have a quick look at that. So here's the formula book, and the product moment correlation coefficient is here, and in practice it's just this section of the formula book that you want. So we've got these values SXY, SXX, SYY, and we can see the formula for these are up here as well, and generally it's just the second part that we're interested in here, and it's just written in a multitude of different ways. So we're going to find those of three values first, the SXX, the SYY and the SXY. Except in this case, because I've got height and weight, I'm going to use H and W instead. So SHH is going to be sigma H squared minus sigma H over N with just this bit squared, and I'm going to have SWW is going to be similarly sigma W squared minus sigma W squared over N. In fact, this needs to be in brackets because it's the whole of that squared, and then I've got sigma SHW, which is sigma H W minus sigma H sigma W over N. So from here I need to then find the various values. So I need N, so N is easy. N is 1, 2, 3, 4, 5, 6, 7, 8 because I have 8 pairs of data. Sigma H is the sum of all the heights. Now if you have a calculator you're able to tabulate this and it will give you the value straight away, but I'm just going to do this longhand today in case you don't have a calculator to deal with it. A graphical calculator is particularly handy as it will do the whole thing for you in one go in a nice easy to see way. Okay, so I've got 1135 there. I need sigma H squared, so that's all those values I just used but squared. And that gives me 162,025. I then need the similar calculations for W, so sigma W is just going to be the sum of all the W's (590), and then finally sigma W squared. Which here I have is 44,200. So now I can plug all that into these various formulae. So SHH is therefore going to be 162,025 minus 1,135 squared over 8. And that gives me 996.875, and I'm not going to round this for the moment because I don't want to lose accuracy. So SWW is going to be 44,200 minus 590 squared over 8. And that's 687.5. And then I've got SHW, which is sigma HW, which I have actually forgotten to calculate, so I'm going to go back and do that now. So sigma HW is the sum of each height multiplied by the corresponding weight. And that's given me a value of 84,420. So SHW is then going to be 84,420 subtract 1135 times 590 over 8. And that's 713.75. So now I can move on to the actual product moment. So the actual product moment that I want, and again we can go back and check the formula book for that. So the formula book says it's here, so it's SXY over the root of SXX multiplied by SYY. So that then gives me 713.75 divided by the square root of 996.875 times 687.5. That gives me 0.862 to three significant figures. And so how can I comment on that? Well, 0.862, well, 1 would be perfect correlation, so this is an indicator of positive correlation. And it's relatively strong as well.